Also, short plug for the people that are here. I will also be at ETH Global Singapore, so be sure to come by. And if you're going to be hacking, come get some merch. It's harder to do merch online, but I will try and give you guys POAPs at some point.
Sounds good. All right, folks, let's start in the next 10 seconds. I know a lot of folks have been waiting in the waiting room, so yeah, let's kick off as soon as possible.
Mm-hmm.
All right. So, hey everyone, and welcome to ETHOnline 2024 workshop titled Deploying Omnichain Fungible Tokens. Joining us today is Matthew, who will be taking us through this session. And with that, I'll pass it over to Matthew to get the workshop started. Over to you,
Awesome.
Matthew.
Thanks, Calvin, for the intro. Like Calvin said, we'll be talking about building Omnichain tokens. A bit of an introduction. My name's Matt. I'm a developer ecosystem lead here at LayerZero Labs. You can follow me at Uncrackable on Twitter. And I think one of the big things that we're going to be chatting about today is that LayerZero is providing you with a smart contract protocol for bridging that is permissionless, censorship resistant, immutable bridge infrastructure. Now, why do any of these things matter when it comes to cross-chain bridging? Well, I like to use this analogy of the real world and kind of bring it back to what we know now about the world around us. We think of bridges as ways to connect isolated groups of people, but more importantly than the people that they connect the flow of information between them. And the flow of information is incredibly valuable because it means that we're able to then suddenly unlock new use cases we couldn't previously do. For example, the coordination of goods and services, and on top of that, the financialization of different assets in the real world. So when we talk about blockchain, it's really no different. At a high level, there are a lot of blockchains that obviously isn't as simple as this breakdown, but might give you an idea of some of the trade-offs you might face when you're suddenly forced to choose between what blockchain you deploy to. And given these choices, developers in our space are starting to move more and more towards deploying on more than one chain. This graph that I'm showing here is from the Electric Capital Developer Report back in 2023. And it's showing that more and more developers are becoming familiar with deploying on more than one chain, but two, using more chains in general as part of their deployment process. And this makes sense. If we think about how token transfers work from a high level, a lot of developers love the simplicity of being able to execute one atomic function call that moves a balance from from user A to user B. In this case, this is an ERC20 token. And you can see here that on one blockchain, it's relatively straightforward. You're able to update a simple mapping under the hood and deduct balance from one user and credit it to another. But one of the main issues that we kind of run into when we think about cross-chain development is that this workflow is no longer atomic. It's not happening in one function call. Suddenly, when you have two blockchains, you're now forced to kind of fit your paradigm between these two isolated islands of connectivity. You have to somehow be able to debit users on a source chain and ensure that that function call goes through, and then be able to emit that message in a way that pings the destination chain and execute a second function call on the destination. And so this workflow becomes a lot more complex. You now have two different transactions across two different blockchains, and you have this off-chain process that needs to notify the destination of what's happened on source. And as a lot of you are probably thinking about, if something invalidates that logic that says what's happening on the source chain, or a malicious actor finds a backdoor, they can control the entire state of the destination chain, which leads to a lot of not so great outcomes. So in general, the way that we fixed this historically was with monolithic bridge security. When I say monolithic, the way you should think about it is that this could be a centralized bridge in the middle where you're fully trusting the bridge itself to relay messages accurately. You could think about this as a collection of signers where you opt in to a trusted security set and you are basically handing your trust assumptions off to whatever the provider is on how many validators they have. Or you could think of it as a middle chain bridge where there is literally a second blockchain sitting in the middle, and that chain is responsible for validating all of the logic between message passing. Regardless of any of these validation techniques that you think of, there was always one main consequence. What happens when that monolithic security fails? One of the big problems with monolithic security is that you, as an application, are forced to trust this set that you have no control over around how messages are verified and delivered to the destination chain. And what that means is if there's ever a backdoor into that validation set, it suddenly means that not just your application's at risk, but every application on the destination chain is suddenly at risk. And this is why when we look over the past decade of blockchain development, the 5 largest hacks, 4 of them are due to this type of monolithic bridge security, where tons and tons and tons of applications are entirely dependent on one channel for delivery. And when we think about this kind of economic security, you can really think about it in terms of some other models that you might be more familiar with blockchain development. This idea that if there is a way to extract maximum amounts of value from every application, this channel immediately has a target on its back. And realistically, that means that there is suddenly a lot more weight to this one validation network that has to stand up. You have to now be capable of defending this pathway against all sorts and sorts of bad actors. So when we talk about security and really understanding what security means in the bridging space, you're kind of in a fixed standpoint when it comes to these monolithic networks. You're forced to adopt whatever their validation is. And typically that leaves you with really bad trade-offs as an app developer. Let's say there are 2 different monolithic networks, right? There's monolithic network A, monolithic network B. On each of these networks, all of the apps that use this type of validation are stuck at either one of these points. If you're picking network A, that means that every app using it is forced to have a low security threshold, but they benefit from it being low cost. Or if you pick network B, every app has a high cost associated with it, but an equally higher amount of security. Obviously, in the real world, it's not as cut and dry as paying more equals more security, but it's helpful, I think, for a mental model to understand this flow. The main takeaway, though, from this graph you should be understanding is that the switching costs for this are very, very high. Once you deploy an application using one of these potential bridging networks, the switching costs are going to become a very large problem for you because you've already deployed your contract interface using those contracts, which means that to change it, you either have to plan ahead and have upgradability built into your contract standards, or you have to pay for the contract changes themselves, potential re-audits to prevent new vulnerabilities from being introduced from the switch, and again, redeploying and migrating liquidity. So overall, the security framework for bridging is very, very unideal for the app developer. That's why I like to say, if you think of Ethereum as being a dark forest, you can think of cross-chain as a dark ocean, where if a malicious actor gains control over your validation network, the pathway or the waterway, your island faces an existential threat for everyone who inhabits it. And similarly, if a centralized entity accidentally destroys the port, the island also faces an existential threat. You can think of this as upgrading your contracts and accidentally introducing a new vulnerability. And so for LayerZero, what we try and think about is this idea of an omni-chain protocol stack. If we were going to, redesign this stack and make it more beneficial to the app developer, how would we design it in a way to protect you from all of those vulnerabilities mentioned before? Well, first, on the omni-chain messaging layer, the way that LayerZero works is that it provides you with the ability to configure the security stack that you want to use for your application. We allow the application layer to choose the level of finality coming from the source blockchain in the form of block confirmations, the number of verifier networks that you want within your security stack, both on the required level, and the threshold of optional verifiers that you want in this stack. And so what that means is that you're no longer dependent on one single network, and you have broad configurability. Secondly, on this function call execution layer, you can think of this as the way that you actually deliver calls on the destination chain. Simply verifying that the source chain state is valid is not enough. You have to also be able to then deliver to the destination chain the actual calls you want to execute. So LayerZero's protocol stack enables you to configure either your own executor or use the LayerZero run executor to basically pay upfront for gas on a source chain and then deliver the destination gas token to whatever application you're trying to send to. This can be really, really useful for just abstracting gas away from your end user. And finally, the smart contract layer, the idea that you should have an omni-chain application standard that makes it easy to communicate between blockchains. LayerZero provides 3 out-of-the-box standards: the Omnichain Application, or OAP, the Omnichain Fungible Token, or OFT, and the Omnichain Non-Fungible Token, ONFT, to just make building these standards and building these applications a lot simpler. Looking a little bit at how this workflow actually works at a high level, the way that you'll interact with the LayerZero protocol is by deploying your Omnichain application that adheres to our contract interface and then calling a send method. The endpoint send method is pretty straightforward. You provide any arbitrary message that you want to send. So if this is a token transfer, I encode the inputs that I want to send as bytes. If it's just raw data, I can code it as bytes as well. I select a destination chain based on the endpoint that I'm trying to send to. And then I provide a send configuration. You can see at the bottom here that this send configuration is basically controlling how long should we wait on the source chain for finality, and then also assigns a job by paying fees to any of the verifier networks and executor that I want to use. You can see here that in this workflow, I've selected 4 verifier networks, and I can configure on the destination chain the threshold of these verifiers that I want to determine finality and accuracy of my message. On here, you can see that my destination app has provided a receive library configuration. And in this configuration, I'm able to set, again, the threshold for finality that I'm expecting to have waited on the source chain, the expected verifier network addresses that should be verifying the actual message that I'm sending, and then the threshold for security itself. Once all of these checks have gone through, the message can then be permissionlessly executed by either any caller on the destination chain or that automatic executor that I talked about before. And all that executor does is simply commits the verified message nonce into the endpoint and then allows us to execute that message to the destination's target app. So this workflow enables you to not only define what you want to send to and what chain and verifier networks, be able to control the threshold of security, and then automatically execute that message to the destination user. A bit deeper about how this interface works, the LayerZero endpoint is an immutable smart contract deployed on both chains. LayerZero Labs deploys this contract, and once that contract is deployed, it's fully immutable, meaning that we can't change any properties of the interface itself. And what this consistent interface gives you is an ability to not only send and receive messages via the endpoint contract, but also be able to configure those application settings like I mentioned before. You can see here in this workflow that whenever I call send, the endpoint is essentially checking for a lower level contract called the message library. This message library is really unique with LayerZero. It basically allows your application to set a specific configuration set that I want to emit messages to. And then this guarantees that your configuration settings are stored on chain and can't be changed by any other deployer than the OAP owner themselves. You can see here, for example, that we deployed multiple libraries that developers can take advantage of. With LayerZero V1, we had this library contract called ULN, or Ultralight Node V2. With LayerZero V1, you were able to select between an oracle and a relayer. But when we released version 2 of the protocol, we wanted to give developers the option to not only improve and customize their security stack, but also take advantage of some of the new execution options that were introduced with the new contracts. And so we added this new message library called V3, which enabled you to not only configure the verifier networks as part of your set, but also the executor that you're using within your message workflow. And so this model of having an immutable interface means that we never have to actually upgrade any contracts on the LayerZero side. Everything is deployed as is. And then if developers want more functionality, we can easily append new contracts that are deployed on chain where the end user will set their own config if they want to opt into that configuration. And so what this actually looks like from the user side is that going back to that security stack versus cost, instead of being locked into a fixed configuration based on your verifier network, apps are actually incredibly flexible. You can have either point A or point B as part of your configuration, and you can have every single point in between depending on what configuration you want to opt into. There are no broad limitations on how large your security stack can be or the type of validation that you use. And what's super valuable about that is that as soon as we add new validation techniques, or just in general, the industry becomes aware of a new proving technology, for example, ZK proofs, it means that existing applications that are already deployed don't have to redeploy their contracts, but instead can update their set config to this new validation technique that's part of the DVN framework and take advantage of that new validation immediately, or if they decide not to, keep their existing configuration as currently set. There's no forced movement between configurations. Looking a little bit deeper at what a decentralized verifier network can be, there are over 34 different DVNs currently live with LayerZero. And really, what you're able to choose between is pretty in-depth. We have ZK Lite clients that you can use with Polyhedra, cryptographically secure state proofs for Lagrange network. If you want to, let's say, combine one DVN that has outstanding security from your standpoint and one that's a lot more, let's say, centralized, like Google Cloud, you can combine these verifier networks and then be sure that they're independently acting from one another, further increasing your security setup. And broadly speaking, anyone can add a new DVN at any time to their application. You can deploy your own DVN, you can wrap generic message passing from other bridge providers. And so this gives you the opportunity to basically build and tailor your security stack based around whatever your
process?
I'm sorry, what?
Can you explain the process to add the new security layer?
Yeah. So when you actually go and set this config, there's a function as part of the endpoint interface here. This configuration basically just takes a raw bytes input. And so there's a struct that you will encode that defines your security stack in terms of the DVN addresses you want. And I think it might be helpful if I just pull it up really quickly here. So this is in the LayerZero documentation. I'll include a link here. This is basically explaining how you can set your configuration. Within this library, you can basically go in and check setting your send config. There's a function here that basically takes these send config params. And within here, you're able to set the block confirmations, required DVN count, required DVNs. If you're looking for what's available, you can find them all under supported DVNs here and get their contract address for every chain that they're on. And if you're wondering how this is actually stored on chain, it's a really straightforward process. If you go to, I believe it's in technical overview here, or sorry, it's actually in, I'll have to remember the section I threw this in. I believe it's in here. If you go to the deployment workflow, yes, you can see here that these custom configurations that you set from all of these endpoint methods are basically mappings from your OAuth to whatever config that you've set. And only you, the app developer, can update this mapping. So good question. I'll link this here in case you want to read through more while I'm going in. But we're going to keep going because I know I have limited time. So moving forward with this, the other thing that you really can take advantage of with LayerZero is this execution workflow. So remember that I mentioned that in the execution workflow, you're able to pay for gas upfront on the source chain and then deliver gas tokens to the destination on your user's behalf. The way that this works is that once the user pays, the executor will automatically relay that message to the destination. And once that message has been verified, like we mentioned previously, the executor can then call LayerZero's endpoint, the LZ-receive method, which calls the OApp's LZ-receive and all of the internal checks that you've added. So for example, if I had my app deployed with in this LZ-receive function calling 3 other applications, I could vertically have it as part of the same stack. But one of the challenges here with cross-chain delivery is that whenever I make a function call, everything has to happen atomically. So let's say even if the call I'm making to contract A and the call I'm making to contract B succeeds, if call C fails, the entire transaction reverts. Now, for some use cases, this is actually intended. You want to have a state where everything either happens atomically or it doesn't. But for other application use cases, this might not be intended or very useful. So LayerZero also introduces this concept of horizontal composability, the ability to basically have your executor interact with the LayerZero endpoint after the message has been verified, and then within your receive logic, make a secondary call back into the endpoint. What this message does is it repings the LayerZero executor on the destination chain to set a second transaction through the destination. And what this means is that if this call fails for any reason, the first call that you've executed still succeeds. There's no revert that happens. And so it enables you to have separate pockets of execution logic that you want to have executed in order. So this can be very, very useful for, say, if I'm trying to send tokens, I can send tokens to a destination chain, and then as part of the second workflow, say swap those tokens for another ERC20 on the destination. Alongside the execution flows, again, going a little bit deeper, you have this ability to drop gas from the source chain. So an end user will call your application. You'll have some settings for how much gas they need to purchase on the destination. And the executor will automatically take care of swapping those gas tokens and delivering them to your destination chain with the gas units that you expect. You can either deliver direct to the application contract itself as part of those function calls that I mentioned previously, or drop gas tokens to an end user's address, which is super handy. So overall, this kind of model builds into what we think of as an omni-chain application, this idea that any smart contract can communicate with a LayerZero endpoint and deliver a message to any blockchain network that they want. So I'll go into this, I think, a little bit later if we have questions, but let's actually jump into the workshop side of this demo. So I'm going to just pop over here, share my window. Actually, I'll share entire screen. Perfect. So can everybody see my window okay? I'm just going to pop a thumbs up in the chat if you can. And should be good. Awesome. Cool. So what we're going to do is go through this LayerZero CLI that we've built that makes it a lot easier to deploy these omni-chain tokens. I'm going to run npx create LZ OAP at latest. What this is going to do is ask me to create a sample repo within my directory. I'm going to call it ETHOnline workshop. And between these options, you should get a few to choose between. You have OFT, OAP, ONFT, which is our NFT standard, and OFT adapter for existing tokens. I'm going to pick OFT, pick my package manager of choice, install. This will install for me and get all of the dependencies that I need for this project. And what this will bring in is basically a sample hard hat and Foundry repo, which can be super handy for just having all of the built out scripts that you need for communicating with the LayerZero endpoint and doing all the things that you need. Awesome. So I'm going to cd into this repo here. Great. I'm going to just run pnpmi, make sure everything's good. Perfect. And to make things a little bit simpler, I'm just going to copy in an env that I already have set up. Actually, I'm going to just steal one a little bit simpler. ETHOnline. Cool. And also going to grab these methods. So within this repo, you have a bunch of preset hard hat tasks that you can take advantage of. We have a few ones related to getting your config, getting the defaults, initializing your config, and ultimately wiring everything together. I'm just going to open this up one more time, go into my code base, ETHOnline workshop, perfect. So you can see what I'm looking at here. In this repo, we have a sample OFT contract. This contract is good to deploy right from the start. What I'm going to do is provide this mint method just for this demo. So I'm going to mint to the message sender 100 tokens. Perfect. Now, what I'm going to do here is first run npx hardhat lz deploy. This should work. Actually, I need to do one quick thing in here in my hard hat config. I need to set my networks. So in here, you can set your RPC URLs for what you need. In this case, I'm doing Ethereum, and I'm going to choose Ethereum as the network name. I'm going to pick Optimism, do Optimism here, URL Optimism. Awesome. Close out this other network that I don't need. So I'm going to deploy my token on both Ethereum and Optimism for the workshop. Running this command LZ deploy, it's going to run a deploy script that's already provided for you in this repo, this myoft deploy. It will look for the networks that you've set up in your hard hat config. You can hit enter. You can hit enter again as it'll just use the deploy scripts you already have set. And then it'll deploy to both these networks using the wallet you have configured in your .env file. Perfect. So you can see my contracts are deployed. The next one that I'm going to run is this lzoap config init. And I'm going to pass in my contract name, which is myoft, and the OAP config that I want to spin up. I'm going to do new LayerZero config.ts. Create for Ethereum and Optimism this default configuration. Oh, I did not want to search there. We're going to just run that one more time. Turn these on. Awesome. And you can see here, this new config file has been created. This holds basically all of those configurations I mentioned before. So this is the block confirmations I'm setting, the required DVNs. In this case, by default, it's LZ Labs and Google Cloud. I can change and add as many as I want and update these mappings, however. And from there, the only other thing I have to do is run LZ OAP wire, passing in my OAP config that I just created, config.ts. Run this wire all. It will check all of my configurations and then present me with the transactions that I need to sign for based on whatever this config file looks like. In this case, there are 10. I'm going to hit yes to both of these. It will sign all of these messages for me. And really, really quick, while this is signing, are there any questions that I can take from the chat right now? Let's see here. Any last minute questions about this? I think this will be recorded too, which will be nice for you guys to just walk back through when you're done.
Yeah, can I ask a question real quick?
Yeah, go for it.
Yeah, so I actually have two. Maybe I might have missed it, but is this so the whole protocol? How trustless is it? And like, if it's like completely trustless, how different is it from CCIP?
Yeah, so the difference I would say from CCIP is that you're required to use CCIP's validator set. It's not open source or anything that you can configure. All of these options that I'm showing here, where you're setting specific verifier networks, let's say LayerZero Labs and Google Cloud, are not actually configurable within the CCIP framework. As part of LayerZero, what I can actually do is if I go into LayerZero's docs, I can go into supported DVNs and actually add CCIP if I wanted to as part of my validator set. So there is basically this configurability between verification that you don't get with CCIP. Going back to this setup here, the other thing you get is that execution framework, so being able to add custom gas settings. What I'm going to do is just copy another task that I've already made called, I believe this is in task/send OFT, and we're going to grab send OFT. Okay, I'll jump over here and just copy and paste it out really quick. So this is my repo. In here, I can set a new hard hat task. I know I'm running a little close on the time here, but we'll try and just get this done really quick. Paste my task in. Gonna go ahead and import it into my hard hat config. And /tasks, beautiful, send OFT, run npx hard hat. You can see LZOFT send is here. LZOFT send. And we're going to send from Ethereum to Optimism this amount of tokens. You should see here, sending this amount of tokens. Link gets populated to LayerZero scan. It's going to take, I believe, about a minute and 15 seconds based on the finality that we've set for it to actually be delivered. But I will paste that into the chat here. Calvin, am I right out of time about now?
Yeah, I mean, we can go ahead for more 2 to 3 minutes for Q&A.
Okay. Hopefully 2 to 3 minutes is good enough. In the meantime, are there any other questions just about the protocol or the tech stack while we're waiting for this to load?
Yeah, I actually asked about the trustlessness and of the whole protocol, and if it's completely trustless, like what exactly makes it trustless?
Yeah. So going back to this like high-level workflow, right? The part that makes it trustless is that within the LayerZero endpoint configuration, there's nothing that LayerZero can actually set or enforce for the app. The app is in charge of setting all the DVN configurations, all the executor configurations. So we can't force you to use any specific verifier network as part of your application set. We can't force you to use the executor. Literally, the only thing that you're using as the application is the endpoint interface. And so the bet that we have is that as LayerZero, we are the ones that have built the protocol. We have a really strong belief that we are able to run really, really efficient executors that you're paying the cheapest fees for and really, really efficient DVNs. So we're hoping to basically compete in this marketplace alongside the protocol for the off-chain setup, but nothing that an application uses is dependent on LayerZero Labs. If we disappeared tomorrow, you could still use your own DVN if you wanted to, use your own executor. And in fact, if you look through the documentation, I'm happy to link to examples we have of building both of those yourself. So Right now, there's also 34 different DVNs that you can choose between. Again, none of those are run directly by LayerZero. They're run by independent parties that have decided to opt into this security marketplace. But yeah, you're able to configure everything yourself as the app developer, which I think is something that you can't currently do with these other application and other verifier networks. And let's see, nice, messages in flight. Hopefully, if 30 seconds goes by, it'll be good to go here. While we're waiting still, the other thing I'll show is basically this trade-off again. So if you're forced to pick between two networks, right? Let's say like one's a middle chain bridge and the other is a set of validators. You actually, as the app developer, have no say in what these network security properties hold. You're basically forced to opt in to their trust assumptions, which is just a very bad design policy for us. It means that every app is locked in to another person's trust assumptions. For us, the way that we want to look at it is actually where apps have full control over the trust assumptions that they have around bridging and are able to configure whatever trust assumptions they want as part of that security stack. So that's at a high level kind of where we're coming from, I think, from a protocol standpoint. But yeah, happy to take more questions in our Discord after this. I think last thing I'll check is hopefully that this is getting along here nicely. If not, I'll post this in our Discord and hopefully should finish up in the next 1 to 2 minutes here.
Can I ask one question related to the event?
Yep.
Is it necessary to complete the checkpoint 1?
To compute the checkpoint, sorry, could you say again?
Check-in 1. There is a due for check-in 1.
Yeah, so it's required that you have at least one DVN as part of your stack. In terms of checking it, so this delivery is happening based on the DVN that you've set. As long as you've set in your receive library that threshold, right, for signing off, you basically are just waiting then for that DVN that the users paid up front to deliver the message to the destination chain. So that's kind of the threshold configuration. Awesome. And if we jump back here, and it's delivered. Awesome. So I think we're just about good to wrap up here. You can see that if we go into more details here, I've not verified the contract, so you're just going to see completely annoying bytes. But if we go into the logs, you can see that we've transferred that 0.00001 amount of tokens to our destination address. We've gotten an OFT received event. It's saying it came from our source endpoint ID 30101, which is Ethereum. And you can see that this is a packet delivered event that you won't be able to see on the Explorer, but if you index it, you'll be able to see just fine. So thank you guys so much for the workshop. Really appreciate your guys' time here. If you have any questions about what I talked about today, go to the Discord under Partner LayerZero, and I will give you guys a happy extended session, I guess, to go through any questions you might have.
Sweet. Thanks, man. It was like really helpful. So yeah, like I said, thank you, Matthew, for joining us today and for the great presentation. Big thanks to everyone for joining the workshop. Feel free to connect with Matthew and his extended team on the partner channel on Discord if you have any questions, and whenever they are free, they shall get back to you. Cheers, everyone, and have a great rest of the week.
Yep. Later, guys.